But in the last 5 years or so, as these new innovations have come at us, we've had to adjust, and we've had to adjust fast. And that hasn't always been easy or pleasant as we go through. So join me on the journey, kind of starting back and then looking forward and getting excited about what you can do moving ahead into this programmable age. We're going to go through a look first at the network engineer of old. What did it mean to be a network engineer over the last 20 or 30 years or so? We'll then look at the ages of networking. I've kind of looked back through history and like any good historian, broke up our history into 4 ages, and we'll tackle them and look at what was important to us in each age and what drove the changes as we went through them. I think we all can admit that cloud and the innovations of cloud and the ideas behind cloud have impacted all of IT everywhere, from application development to infrastructure and into networking. And so we'll see about what has happened when cloud came to rescue everything and how has it changed IT for us. We'll talk about net DevOps and how that fits into this journey that we continue to go through. And at the end, we'll look at what it means to be a network engineer successfully today and into the future. What skills do we need? What types of challenges do we have? What should we be interested in taking a look at? So, we are going to start out with a look at ye old network engineer. You're going to see me throughout this presentation refer back to a good friend of mine, Carl, the network engineer. He's been doing networking for years, and he's been out there like most of us. And he comes back from the land of write mem or copy run start. Right? Anybody else put an alias in their Nexus gear so they can continue to use write mem, or was it just me? Right? I see some other guys out there. Right? We don't like change. And Carl's like any of us, right? He didn't like change much either. Now, Carl's been doing this job for a long time. He's a senior network engineer in his organization. All the junior network engineers look up to Carl. And he's developed himself a set of skills, a very specific set of skills that set him aside and made him well suited to be a network engineer. And like any network engineer, his skills start with a foundation in spanning tree. Spanning tree, the root, every pun intended throughout this entire presentation, the root of every network engineer's fundamental knowledge. But he's not a layer 2 only guy. He can route like the rest of them. Routing protocols. He speaks BGP, EIGRP, OSPF. He's been known to jump back and forth between OSPF and EIGRP in those debates that happen. Open source or standard versus functional and fast and easy. And he's also kind-hearted to all the junior network engineers that tentatively suggest, well, why don't we just use RIP in our network? Right? And he pulls them aside and very calmly explains that while RIP is important to learn the fundamentals of routing and how we get across the network, nobody in their right mind would run RIP in their large enterprise production network as it goes through. And if you are, you feel free to look down, that's okay. QoS. As Carl was part of the network engineering team, more and more applications joined his network, and he had to learn how to build policies and mark and shape and police and avoid all of those Netflix bingers from taking up all the bandwidth and keeping them from the production business apps appropriately. Spanning tree. I mean, spanning tree is so important to Carl. He understands every knob, every setting. He would never leave a default set to default. He would never allow a root bridge to automatically be elected. And he tells a great story. It happens at least a couple of times a year. He's at the lunch table, everybody gathers around, and he talks about the great spanning tree outage of 2008. It was 3 a.m., he was in the cold data center, wrapped in a blanket, hyped up on Red Bull and Mountain Dew, looking at the rack in front of him of the 6500, and the lights were just going nuts. Blink, 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 blink. Network had been down for hours, nobody knew what to do. And it was inspiring. He felt like Radia Perlman herself was over his shoulder, guiding his hand as he reached out to that fiber cable and unplugged it. And the network became calm as the bridging loop ended. I mean, I still get chills telling that story. And we've all got those stories, the horror stories we went through. Who's got a spanning tree horror story? Come on. It can't just be me and Carl, right? We've all had those moments. Remember when voice joined the network, right? It used to be a data network, and then it was voice and data, telecom. the great voice over IP change as it went through, and he learned a little bit about SIP, right? He dipped his toe in the water of applications as they went through. And then storage joined the network, fiber channel, FCIP, iSCSI, all these things popped up, security, MPLS. Did I mention how important spanning tree is to Carl and his network skills as they go through? Carl built his career on his network skills and his prowess as a network engineer, operating, designing, building networks. And along the way, he picked up some programmability skills. He never would have called them that, but when he took his CCIE, he learned how to use Tickle to ping every interface to save himself time. He learned how to use EEM to avoid all of those 3 a.m. phone calls when a junior engineer shut down the wrong interface. And after too many copy and paste errors, he learned about expect so that he could work into those. Like, he built himself up a skill set. And these skills served Carl well for years. He moved up in his organization, started as a network analyst, an administrator, engineer, finally architect. And these skills were developed when the network looked like this. Anybody remember when the network looked like this? It was awesome. We had routers and switches and our servers connected to our switches. We could walk into a telecom closet or a data center and we could touch our network. It was teal green and had Cisco silk screened in white on the front, right? Let alone the fact that we paint stuff in different colors now. I remember the first time I saw a Cisco switch that wasn't teal. I didn't know what to do. All right, things are changing all over the place for us. And for years, the network looked like this. And then things started to adjust. The network changed. The first hint of the change in Carl's network was when these guys joined. The V switch, the virtual switch. I mean, come on, a virtual switch? Switches aren't virtual. They're not software. Switches are big hunks of iron that take 17 engineers to rack mount. Big, giant power cables that plug into them, that take down entire fuse boxes if you try to put one in your basement. I know, I tried. Giant switches, that's what a switch was to Carl. And VMware, this little upstart software company, comes in that their sysadmins were toying around with. And they had V switches, virtual switches. Well, when these came into Carl's network, he did what I think a lot of us did. We looked at it and said, that's not real networking. It's not a real switch. That's software. You know what, server guys, you take care of that. Us network guys, we're going to focus on the important network, the routers and the switches, the physical ones that I can touch. And that went on for a while, and we had all of these server guys playing around with V-switches. And we all know nobody would ever put anything of importance on a VM, so why do we bother even with them? It didn't stop here. Shortly thereafter came the blade server explosion in the data center. And blade switches came into the environment. They weren't even always called blade switches. They were I/O modules or bridge modules, because I don't know how we convinced ourselves that a bridge module wasn't the same thing as a switch, but we did, because Carl looked at it. And these blade switches, they said HP or Lenovo or IBM, Hitachi. And network teams didn't even pay for the blade switch. Came in on a server bomb. Didn't come out of my budget. It's not a network piece of gear. You know what, server guys? You take care of those. We're going to continue to work on the important network, the real network, the routers and switches, right? That's where the network goes. And it still didn't continue. The pace changed and accelerated. And most recently, coming into Carl's environment was this part. Little itty bitty baby C's that stand for containers. And my favorite part of the new network, the LBR, because I get to make a pirate joke. Right? The LBR, the Linux bridge. The Linux bridge lives inside of virtual machines, hosting containers. And so now we have critical applications being built where their network connectivity is through a software bridge running on a Linux server behind a virtual switch in a server that's connected to a blade switch. And now, finally, we get to the switch that Carl thinks is the network. Has anybody been through this in their own organization and realized that the network is now so deep and so far away from what we thought a network was that we didn't know what to do with ourselves anymore. We had new network teams spin up in our organizations dealing with all of this other stuff that we didn't want to. And that's not good. Now to go even further, let's not forget about the cloud, right? We extend all of our resources out to public and private clouds. Solutions like AWS and Google and SoftLayer and Azure and all of these ones. And inside of the cloud, we have all sorts of new challenges, but we also had an opportunity to get excited because we had cloud exchanges, right? I know I'm not the only network guy that got exposed to a cloud piece and laser focused on the cloud exchange concept because it was something I could grasp. I understood how to extend one network to another over T1s or MPLS or direct connections as we went through, how to do routing across and segmentation and tunneling. And yes, that's part of our cloud discussion, dealing with the exchange. How do we connect the cloud to the rest of our environment? But the more important part of the cloud is what happens inside it. We have virtual machines that connect to a network that never touches one of our physical switches. Those virtual machines might run containers. And then there's the black magic that is, where'd my mouse go? That is all of these things that exist in the cloud as services. I can order a database as a service that isn't even on a virtual machine anywhere. I can have directory servers, Lambda functions, function as a service that is nowhere near anything even remotely close to what I'm used to. The cloud brings all new networking pieces. Now, despite the fact that I never have a router or switch inside the cloud that I can touch, they're all still doing networking. Who's responsible for that network? Who's designing those networks? And I know somebody out there realizes my slide is completely unbalanced, so let's finish it out. There's all these other things that are part of networking too. Load balancers and firewalls and IDSs, lions and tigers and bears, oh my. The network is not just can I route, can I get across. The network is DNS resolution. It's application delivery. It's dealing with all of this new stuff that goes through. I started this slide back where the network was routers and switches and servers. How many of us, let's be honest, how many of us, when you see the word network or you talk about network, that's still what you think about? Routers and switches and servers. It's me, it hits me every now and then. I still get to that spot. But the network today is made up of so many more things, right? It's not that the routers and switches aren't still important, right? They're still a core element of our environments, but they're just part of the network. And frankly, somebody has to be a network engineer for this entire diagram, and I would much rather it be all of us than somebody else. Because I got into networking because I wanted to connect things together. And whether it's a function as a service or a container or a new load balancing type capability, those are still connecting, and I want to be responsible for those. So this, I know I probably scared a few folks, depressed you all. Let's go back to something that I know we'll all relate to. The OSI model of networking, layer 1 through layer 7, and we all learn cute mnemonics to remember them so we can pass our tests. But if we're honest with ourselves, we all know that there's really only 3 layers to the OSI model. There is the, oh yeah, we got this layer, right? It's the top part of data link where MAC addresses live, through IP addresses and into TCP and UDP. We got it, right? I speak TCP, I speak UDP. I can subnet with the best of them. The oh yeah, we got this layer. We also have the black magic layer. Down at the base, all of the rest of the data link layer that isn't MAC addresses, and then the physical layer. Be honest with me once again, because I know I'm not the only one. We used to understand the physical layer. I could punch down tools. I knew what the difference between a straight and a crossover cable was. I could make these. And then we invented auto MDIX, and it feels like I got rid of all of that knowledge. And the extent of my troubleshooting the physical layer is there a link light? And if it's fiber, can I flip the pairs? That's about all I get, right? The physical layer is becoming important. We can cram so much data through fiber today. Two strands of fiber, we can get up to 100 gigs. 400 gigs aren't that far away, which means now I have to know the difference between all the protocols. Do I have the right fiber cable? Do I have the right end? Do I have the right transceivers? Those transceivers pull a lot of power. Do I have enough power going into my switch to power all of those things? Like, I have to understand the physical layer. And even in the data link layer, as we start to see new things hit layer 2, we've got to understand those better. And up at the top is the please don't ask me about these layers. I mean, let's be honest, it says application. That is not a networking thing. The application layer? Nah, somebody else will handle that. But once again, today, the programmable age. In whose organizations are there microservice or DevOps teams building cloud native applications? I would expect everybody's hands to go up because everybody is doing that. Those applications rely on APIs. The vast majority of those APIs run over HTTP. Who knows what HTTP is? Raise your hands, because I know you all do. Now keep your hands up if you know HTTP is more than just port 80 and port 443. Right? Okay, that's good. We have to understand HTTP because that's where it goes. You have to know the verbs. What is a GET? What is a POST request? What does a patch request do? How does authentication function? The language of the network as well as applications is turning into JSON and YAML and XML. Well, guess what? Presentation layer. How do we establish sessions across the network so that we can keep communication paths going correctly? The session layer. These are all critical skills. When we look at the OSI layers, we have to extend ourselves out of just our comfort zone of layer 2, layer 3, and layer 4. Right? Load balancers no longer operate just at layer 3 and layer 4. The vast majority of load balancers being deployed today operate at layer 7. Right? We can have a load balancer, load balancing hundreds of web servers and API endpoints all off the same IP and port. And they do it by addressing the host name. That's a layer 7 load balancer. If we want to continue to work with load balancers, we have to understand layer 7. We've got to bring ourselves up. Get excited about what's new out there. So what changed? Like, how is things going? How have we evolved networking as we've gone in? And so let's journey through the ages of networking, starting in the Stone Age. And I don't call it the Stone Age of networking as a bad thing. I loved the Stone Age of networking. It was easy. We had the wheel. What else did we need? The wheel for us were spanning tree and VLANs, right? The good old days of networking, where we relied on spanning tree. It's been there from the beginning because we knew we needed redundant networks. We wanted to have more than one cable, so if something went down, our network was good. But in the Stone Age, if it took a minute to converge after a problem, nobody really cared. It wasn't a big deal. And VLANs. We've had VLANs for a long time. And in the Stone Age, we had lots of debates in our organizations. Do I put my printers and my workstations on the same VLAN? And we talked about the pros and cons of separation and segmentation at that point. But I know a lot of houses got down to it and said, you know what, let's just put them on the same VLAN. It's easier. I don't have to deal with routing. I don't have to do these SVI things. We'll put them all together, all right? Stone Age of networking, spanning tree and VLANs. Stone Age lasted for a while. And then the .com era came, new things brought into it, and the network had to up its game a bit, which brought us into, the Bronze Age. Now I'm too far. The Bronze Age of networking. And the .com era, everybody was building wide area networks. And so we had to learn about routing protocols a bit so that we could get from one of our sites to a manufacturing plant, across the WAN. We had WAN design, and we partnered with service providers to build large point-to-point types of networks, right? IP-mageddon, IPv4 address exhaustion, right? Remember when that happened? And I know every one of you in your networks back at home are fully dual stacked. You've got IPv6 pushed all the way down to the endpoints because of the importance that IP-mageddon had. I wouldn't put it up there at Y2K with overblown, but it was pretty close. We handled IP-mageddon in the simplest way possible, NAT. That's how most of us have done it, and we'll get to it eventually. The Bronze Age lasted a short amount of time, much shorter than Stone Age, but it still lasted a while. And it wasn't until we got to kind of the SDN time frame where the renaissance of networking popped up. Software-defined networking, that idea changed everything. And like the Renaissance in art and industry, the Renaissance brought in tons of new ideas that were going to change everything for us fundamentally. OpenFlow, Disaggregated switches, giant controllers, dumb white box switches. That's what everybody's network was going to look like. And some of them have, but not so many. Overlays we had. MP-BGP, multi-protocol BGP. I mean, come on, I barely understood BGP with one protocol, and now we got to cram more than one in it? So tough. My favorite part about the Renaissance was VXLAN. So I've been at Cisco for about 10 years now. I spent about 8 of those in the field as a solutions architect, pre-sale, so got to hear all the marketing things. And if there's one thing I've learned from 10 years at Cisco is that if you have a product and you need to reinvigorate it, you put an X in the name. So VXLAN, VLANs for the Renaissance. That's it. I think that's really all it was, is we needed something new. VLANs were old. We needed something different. VXLAN. Microsegmentation, white box, all these ideas came at us in the Renaissance. And the Renaissance didn't last forever. It didn't last all that long, really. It brought in a ton of ideas. It made us question why we did things, which was good. We needed to question. We needed to figure out why networking hadn't changed that much and what new things could we do. But the Renaissance gave way fairly quickly to what I call the programmable age of networking. This is the age of when cloud started to really mature, where cloud is not a destination, but a strategy for delivering IT. Where Python is becoming the go-to language for infrastructure and network engineers. Everybody out there wants a REST API and new ways to program their devices. We build fabrics instead of network. We're virtualizing just about everything. And containers and DevOps, these are the things we're all after as we go in. Now the rate of change from the Stone Age to the programmable age accelerated like a hockey stick, man. It was crazy how fast it went. And you might be wondering, like I did, is why? Why did it accelerate? Why did it change so quickly and so much? And this next slide I feel a little bad about showing because I pride myself on not just being a marketing guy, but I think there's some truth to it. The digitization of the enterprise is what has pushed so much at us in IT. Anyone else been in a meeting like this? I want an agile, bimodal, hybrid cloud so we can develop our containerized, serverless, trustless microservice applications to take us digital and avoid the disruption from the unicorns. And I want 2 DevOps. These conversations are happening in IT leadership and business leadership, pushing changes. Now the digitization of the enterprise has become a buzzword. I imagine you're probably going to hear it in the keynotes and in different sessions that are out there. But as an engineer, I wanted to ask myself, like, what did it really mean? And I broke it down into 3 things. The digitization of the enterprise is about an app economy. Most of us today have smartphones, and those smartphones are full of apps. Apps that do everything from let us fling little birds at pigs, to control the lights in our house, to interface with our doctors, where we have an app economy. Getting technology and information into the hands of users is what it's all about. And every organization, whether you're focused on consumers or business to business, manufacturing, finance, is being pressured to deliver faster and better user experience because it's being demanded. And if your organization doesn't do it, some competitor or some startup will do it and take your customers away. Huge fear, huge pressure on all of our businesses to live in the app economy. The Internet of Things, or if it isn't connected, don't bother, what I call it. About 5 years ago, I was meeting with a customer. They're consumer manufacturing goods. Think like toasters, washing machines, microwaves, all that type of stuff. And I asked them, again, 5 years ago, what percentage of your stuff is smart or connected, right? And at that point, it was about 5%. It was just the premium line, and I knew that because I had recently been in the market for a refrigerator, and even as a tech nerd, I wasn't willing to spend the amount of money for a smart refrigerator at that point. In the same meeting, I asked them, 5 years from now, what percentage of your devices do you expect to be smart and connected? And without missing a beat, the answer was all of them, because they knew that's where the drive was. 5 years ago, nobody knew why they wanted their washing machine and their toaster and everything connected to the internet, but we're starting to get hints of it, where your refrigerator can notify your stove what's for dinner and the temperature to put it up to. You can talk to your house and it can update your grocery list as it goes through. Like, we're starting to see why IoT and connected is there. But as everything is joining the network, IPv6 will become important finally for reals, not just for fakes. But security comes in as well. How do we secure when our network doesn't live just in our data center or just in our locations or just on the laptops of our employees, but our network is extended to the edge of every device we've ever sold? We've seen DNS taken down by baby monitors, right? These are real things that are happening. Internet of Things is adjusting how everything has to go. And the tech unicorns. The barriers of entry are being lowered so far that anybody with a credit card, a good idea, and a garage can be the next billion-dollar business. And organizations don't want to be disrupted out of where they're at. So this is what's adjusting it. So how do we solve the digitization? How have organizations and enterprises seen these problems and figured out to solve it? I'm sure you all have gone through this, so I'll keep you in suspense for no longer. It's the cloud. The cloud will fix digitization. The cloud will prevent all of those digital unicorns from causing us problems, because we'll be one too. So every one of our organizations set out to build a cloud strategy. A cloud strategy that looked like this. It was the unicorn of clouds. Every organization set out thinking that they could build their own AWS or Google, provide their own cloud strategy and do it just as well, do it cheaper, do it more efficiently. And everybody sat out with this in their mind: strong, pristine, beautiful, powerful, the dream of every 6-year-old girl, the unicorn. But time and time again, enterprises went after it and they ended up with the donkey corn, right? Poor Teddy gets so much slack in my presentations, but he's the symbol of so many burned out cloud projects as they've gone through. And the reason this has happened is so many organizations thought, well, we know how to do IT. I can just take the way I do it now and slap a little bit of software on it, throw a service catalog, shove it out the door, the developers will be happy. And so they didn't end up with unicorns, they got donkey corns. Through no fault of their own, it was an honest mistake, and I can show you why it happened. It happened because of the cloud gap. Every organization that tackled these had this issue. They have their architects and operators, us, down at the base, dealing with infrastructure, OS, cloud management, automation. And then at the top are the developers and the users that just want to develop their stuff, right? Make their stuff work. We would deliver a donkey corn, this. Well, we're not there, we're not connected, because there's all this other stuff in the middle that's required. There's this new application and middleware layer built on top of open source solutions. Containers, scheduling, all of these other things have to happen. You have to fill the entire gap as it goes through. So who manages these other layers? Do we reach up? Do they reach down? I've seen it go both ways, but the most successful is when we put in a new breed of team into the IT organization, the DevOps engineers, right? They come in and they split the gap. They take over management and automation, they offer delivery pipeline services, and they kind of do this translation for us. So the next question usually is, well, where do DevOps engineers come from? Are they birthed from the fertile ground of burned out clouds with unicorns crying on them and sprout? That'd be cool. I'd love to see that in a movie, but that doesn't happen. DevOps engineers come from both sides. We have DevOps engineers that started their world as architects and infrastructure people and found they liked open source, they liked coding, they liked containers, so they moved themselves up. And there are plenty of developers that came out of school and found that they hated programming in Java or JavaScript, but they liked working with the open source pipelines and Kubernetes, and so they drift down. And so DevOps engineers actually bridge this gap nicely because they're made up of both. And I started out talking about cloud here. Here's where the cloud is. If all you are focused on delivering are the bottom 3 layers, you are offering infrastructure as a service, IaaS. What people really need and want are the rest of the stack. That's where the platform as a service comes in. They're building applications on a platform, and you have to build those. So to deliver this successfully, we have to remember that there's 2 stakeholders involved in every network. There's us, the network builders. We build, we design, we operate, we care and feed. But there's also the network consumers, the users of our network. They want to consume services. They expect it just to work. And consumers have always been there, but the services they've wanted used to just be, can I get a network cable? Now they want segmentation, they want agility, they want analytics, right? These are different requirements that are coming through. They want control. And this is where Net DevOps comes in. How do we connect these dots together? And so back to Carl, remember Carl, and now we see his twin brother, Captain Cloud. Captain Cloud was always a software development guy, so he gets software, he gets DevOps. But he wasn't sure what Net DevOps was or why the term was even invented. And so as Carl explains, Net DevOps is about taking the culture, the best practices, the tools and ideas from DevOps and applying them to networking. We can't just do DevOps the way that they do for software in the network exactly as it is, because there's differences in building networks than building software. I'll give you one really easy example. Most software teams, when they make a change to their application, today with new applications, they have their existing app, they spin up a brand new application, all new VMs or containers, new services, new rules, everything is brand new, and then they destroy their old application. How many of us have the luxury of, if we need to add a new VLAN or network to our data center, we're allowed to build a brand new data center where this new VLAN will exist and then destroy our old data center? Right? We don't have the ephemeral nature in the network, so we have to take the ideas and figure out how do we apply them to networking. And that's why I like the term Net DevOps, right? We're networkizing these ideas. Net DevOps has a lot to it. We're going to hit a couple of pieces here, but the biggest one is this change in culture and mindset. By and large, I talk to folks today that are afraid of their network. Right? Anybody out there willing to admit that you're afraid of your network a little bit? Changes in our networks rarely happen, which means they have to be huge and complicated. We get one shot a year to touch our network, which means we have to upgrade firmware, change routing policies, ignore the policy maps, because nobody knows what those do, connect new stuff together, bring on new pieces. We get one shot a year, everything has to happen, which means we're afraid to go in. And we're not practiced. We only get to do it once a year. That's not that often. And so every change is seen as a high risk. And they're monitored heavily by everybody, from your managers all the way to the executives at the organization, because every network change is seen as a gigantic risk that everybody has to come together for. And I don't care what the change is, some problem is going to happen. Not a burn the network down problem, but something doesn't go exactly as expected, because we're trying to do so much, it's impossible to anticipate everything. And so something goes wrong, it's seen as a failure, and so changes rarely happen. It's a reinforcing loop. We need to break the loop and get to a culture of change where we put it on its head. Changes are all the time. We do small changes. We do them all the time, so we're practiced. They're not seen as a risk, and we're allowed to keep reinforcing. Now, going from one side to the other is easy on a PowerPoint slide. I just had to hit a button. In real life, that's a lot of work. We have to get ourselves there. And that's trying to figure out how to do that as part of Net DevOps. Some of the things we'll see are these ideas of treating the network as code, right? So the DevOps idea of infrastructure as code, I want to extend that to the entire network. I want to work inside of source control systems like Git and GitHub. I want to have branches that represent my proposed changes, automation routines and pipelines that will spin these for me and test and validate. To do this successfully, our tool bag, our tool chest has to change. The Net DevOps engineer's tool chest is made up of different categories that we've had in the past. Source control, continuous integration, device interfaces, controllers. If I pick on a couple of the drawers, source control. Source control systems are a place where we can put all of the configuration, the code that drives our network, where we can collaborate on them, where we can understand what changes have been proposed, why, who did them. We're going to take advantage of new network service and config management tools from the commercial as well as open source community, like NSO and Ansible and Napalm and Python. These are new tools that we have. We're going to use interfaces like JSON, RPC, RESTconf, gRPC, all of these new pieces that go after it. And then controllers are becoming part of many of our organizations, whether they're open source or commercial solutions like DNA Center or APIC from Cisco. These are coming after it. The new tool bag for us looks like this. Now, I've been going for about 35 minutes now. We've talked for a while. I've told some jokes. We had some laughs. You saw some cartoons. It's always right about now in the presentation that I look out there and I see lots of faces that look more like that one, right? We get a little overwhelmed, maybe a bit angry. Why is it so hard? Hank, you told me you were going to inspire me. It's okay if you're out there and you're frustrated and you're angry. That means you've moved past denial. 5 years ago, I'd have these conversations with organizations and I wouldn't get anger, I'd get scoffed at. You are crazy, Hank. Nobody cares that it takes us 2 months to do a network change. Our business doesn't go that fast, right? Copy and paste works great for us. No, I don't need to upgrade my iOS. We're good on that release that you guys had 10 years ago. We're fine. That was the type of stuff I used to get. So I'm happy when I get anger, when people are upset. But we want to move ahead. We don't want to get stuck there. We need to get to acceptance. Get through all 5 stages of grief. Be excited about what's after us, about the challenges that we have. Which brings us to today's network engineer, and back to Carl. So the answer is that you need to find a Dr. Frankenstein and strap yourself to a table and undergo routine monster surgery and be struck by lightning to fix all of these problems. That'd be kind of cool. That'd also make a good movie. But that's not what it takes. Carl put himself together a 3-phase approach to tackle this strategy. In phase 1, he stepped away from networking for a little bit and learned some things about Python, about APIs, JSON, XML, right? Picked up some of these new fundamental pieces, went back to school, so to speak. Once he was comfortable there, he moved up to phase 2, where he toyed with Linux. Because yes, Linux skills are going to become fundamental to every network engineer. That doesn't mean we all have to become big, bushy, beard-wearing Unix sysadmins. It just means that we have to be comfortable at a bash shell, know what the etc directory is for, know how to tal a log file occasionally, like simple Linux administration skills, because all of our devices run on Linux today. In phase 3, we start to bring in some of these new networking things, Linux networking, container networking. We need these fundamental skills to be successful as we go in. And coming out the other side, you too can embrace programmability and update your CV with all sorts of new skills. The networking skills don't go away. In fact, we get new networking skills. We get Linux networking and container networking and cloud networking because we want to build the networks that are foundations for our applications today in all of those areas. We get some platform skills, Linux administration, container administration, microservice platforms. Now you might be wondering, well, I get understanding Linux networking and container networking and cloud, but why do I need the platform skills? Well, it's because if we're going to build a network for those platforms, we kind of have to understand how they work. So before you dive into CNI plugins for Docker or Kubernetes, go figure out how to just bring up a Docker application. Get some fundamentals under your belt, then move into the more complicated networking pieces that are there. And yes, you will get yourself some programming skills, data formats, Python, API languages, source control systems. You'll build yourself a skill set that goes in. Now, I know what a lot of you might be thinking, that is great for Carl. We love his journey. He's done a great job for himself. Nice new shirt. But what about me? Right? I'm still way back here in the Stone Age, worried about VLANs and spanning tree. How do I evolve myself? Well, joining us here in DevNet today, that's a great start to go through. In fact, we have an entire area here in DevNet Zone called Start Now at the other side, where we can help you, give you some suggestions, help you get your laptop set up, suggest learning labs, suggest sessions that you can tackle. You can even sit down with one of our expert mentors to talk about what you should start with first based on where you are today and go through. And outside of Cisco Live, DevNet is always here to help. We're constantly putting new material together to help jumpstart everybody's journey into network programmability, explain these pieces, put out new material and videos and events and learning labs and webinars. So if you're not already a member of the DevNet community, be sure to sign up while you're here. We even have some great stickers and swag to go through to entice you to join DevNet. We have a monthly newsletter so you can get the latest types of events and information that are going through on there. So as I come to the end today, I'm going to leave you with one more cartoon from Captain Cloud and Carl. I know all of us, and I felt like this a bit this morning actually, right? Just wanted to give up, right? It felt like too much. All of these new terms, all of these new ideas, all of this stuff coming at us. Why does it have to be so hard? Why does everything have to be so new? And while Captain Cloud is allowed to do it because Carl's family, I'll be a little gentler, right? We have to keep up, but you don't have to be at the front of everything. It's okay not to know something. What's not okay is to not be open to learning new things, right? We have to be open to go out there. And we have to be okay saying, I don't understand that. It's one of the hardest things that I had to learn to do was to admit when I didn't understand an acronym that somebody said in a conversation. But things are changing so quickly. Be open, ask the questions, join the community, help each other out. Because I guarantee if you feel you're lost in one topic, the person you're talking to is probably lost in something you understand. And if you communicate with each other, we can help everybody come along as we go through. Now, as you leave, I will stick around for some questions as we go through, but if you've been inspired by Carl's story, I have layered out some stickers here in the front of Carl and his journey to Net DevOps. So grab one, put it on, be proud of that. But remember, there's all sorts of material that's out there. We've journeyed through the 4 ages, we've talked about cloud and Net DevOps, but we've got material that you can continue your journey as you go through. I've written a series of blogs, video series that will help you tackle some of the practical technical skills through all of these as you can dive in addition to the labs and the exercises that are here today. And please do join our community, stay in touch, right? Reach out to me on email or WebEx Teams, join us on social media. I'm HF Preston, Cisco DevNet's out there doing all sorts of different pieces. Stay part of the community, help us all out. Because that's been my most exciting part of my own journey here, is meeting so many people that are in the same place I am. Learning from you, helping somebody else learn something new as it goes in. Again, thank you for joining me as we went through today in this journey. If you want to see the next half of this, tomorrow at 1, I'm back in the theater, diving deeper into Net DevOps and its impact on an enterprise and an organization. We spent today talking about what we have to change inside ourselves. Tomorrow, we'll talk about how our enterprises have to adopt and change their culture and processes. And that's a great kind of second half of this session today. I will stick around for a few questions if anybody has some, but feel free to head out and enjoy the rest of Cisco Live. Thank you.